Just a random perusing of the tweets.
Yeah. Episode 14, Driveline Baseball R&D podcast. Well, actually, Driveline R&D podcast. Research and Drinks.
Driveline,
I'm your co-host, Alex Caravan.
Driveline, Research and Drinks, episode 14.
Okay, bro. It's rude to interrupt me when I'm already going.
May
I know
10th.
I fell back a little bit. Episode 14, 9 p.m. on a Sunday. Our latest episode yet. I know it says I'm drinking right here on the overlay.
I guess if you're talking time of day, it's our latest, but we did one Monday morning one time.
Okay, starting from the top. Driveline R&D podcast, episode 14, 9 p.m. on a Sunday.
Research and Drinks.
Filmed on May 10th, 2020, episode 14. Says I'm drinking a Rainier and overlay, but we spend way too much time figuring out Lindley's weird buzzing in the background. So your boy's now onto a Lush IPA. I'm Alex Caravan, co-host, co-swag manager of Baseball Analytics.
I'm Kyle Lindley, R&D engineer, Driveline Baseball, co-host, Driveline Research and Drinks, drinking a Modern Times coffee roasty stout.
Yikes. And I'm Anthony Brady, biomechanist, Driveline Baseball. And as Alex mentioned so eloquently, this is episode 14.
Yeah, and if you
podcast.
If you hear nothing from Lindley at some point during the podcast, it's because he has a lot of cars in the background, as he has now moved in a somewhat more active area of the city.
That's actually the big topic of the week and next. Well, we won't talk about the next week one, but the last 2 weeks moves out of the old facility into the new, not quite into the new facility, but most of it. Lindley moving, got a little closer to us. That's fire. Stoked about that. West Seattle gang, living by the beach.
Yeah.
Speaking of those, since we're really close proximity-wise, my friend Mikey, an old business partner, texted me today, like challenging me to the Murph workout. You know what I'm talking about, the CrossFit workout.
That's what we were talking.
For like a time.
Yeah.
Were we? You don't know what I'm talking about?
We were talking about that once.
Murph?
Weren't we? Like, what's the best time?
Yeah.
Just
like we were looking it up online. Yeah, because
just like a while ago.
Yeah. Because technically, you're supposed to have like a 20-pound weighted vest on.
Mm-hmm.
So we're trying to figure out if like the times were with the vest on or without.
Right.
But we can do it without the vest. But Lindley, I'll tell you the workout is real quick, and then I was gonna pitch you on if you wanted to even go at it sometime this coming week. I think it could be pretty fun. The workout is, I think it's supposed to be like in somewhat of an order. So you run a mile.
You sandwich the miles.
You run a mile at the beginning and run a mile at the end. I think in between you can break it up however you want. But it's 100 pull-ups, 200 push-ups, 300 squats, all body weight. Well,
with the vest. For time. With the vest.
Wait, how many push-ups?
200. But we can do it without the vest and just go, do it as a competition, like hash out what we think is a mile. There's like a playground real close to my place. So, and then in Lincoln Park, there's like a a pull-up bar, because that's all we really need. The only equipment we really need. But if you're down to make it a thing, I think that could be really fun.
I can't bet on it. I'm not in the same league as you. I'd have to be in a different division. The pull-ups are going to slow my time down way too much.
Caravan,
I would literally have to do like 30 sets.
Damn, dude.
30 sets of pull-ups to get to 100.
Bailing?
I would have to do like 150 sets. I think it'd literally just be like half pull-ups.
Yeah.
All right. How about this? Sure. You guys can split the pull-ups. Lindley, you do 50. Brady, you do 50, and I'll do 100. And then we'll time.
That makes no sense. I literally can do one pull-up, and then my shoulder feels like it's gonna explode.
Devin and I have been looking into marathon training programs, so we might shoot for one in middle of September if you want to join.
I'm down.
If I was gonna go the marathon route, I'd want to do like the triathlon or like Ironman sprints route.
No, yeah, definitely. And I want to do an Olympic triathlon at some point, but I think I might hit a marathon first.
Yeah, I've been on marathon. I'd be like, when were you thinking? September?
Mm-hmm. Give a good 16, 18 weeks of training, so you didn't have to do it super fast. I told Devin.
I ain't training, dog. I don't need to train and dust you in a marathon. I can just hop in that.
It's funny because I told Devin that I was like, we just won't train with Caravan for at least the first like half of it, because Caravan's the type of person to just like do a whole training program in like 2 weeks or whatever.
In
And
2 hours.
Yeah. And then just run it.
My training will be the
anyways.
first half of the marathon. Then the second half, I'll be warmed up.
His training
Also-
program is getting an additional like hours like of sleep the night before.
Quick update before I get into what I did last week. This beer is actually kind of fire.
Really?
Dude,
It's
I
a
mean,
pretty-
I haven't said anything, but I'm in a modern times and I'm in a step, so I was pretty jelly when I saw that you were drinking that. I'd be in on that.
Yeah,
Does it have caffeine?
I think it does.
It
And
is
they-
coffee, yeah.
Mhm.
I'm intrigued
Last
by it.
week, did some planning for study writing. The stuff that kind of ends up seems to drag out studies a little bit longer. So trying to keep that organized so we can get those out to publications as soon as possible.
Nice.
Did some moving with Anthony today, and for the facility move, and then moved my own home to West Seattle, as they mentioned, which is a way cooler spot than I was at earlier, despite a little bit warmer temperature in my room. We'll have to figure that out.
Well, you said you said you do have a fan or don't have a fan?
I don't have a fan yet, but
So
I'll.
do you guys have like a roof? That was dumb. Do you guys have like a balcony or like an area? Like I hope to God you have a roof.
We don't have a roof floor where we can go up and like stand on the roof, but my room, there's no master here because I'm still sharing a bathroom, but I have a balcony attached to my room, which is cool. And it's facing the water.
Okay, you can see the water from your balcony?
Yeah, just like through a tree, like over a building, but I can see the water.
That's still tight.
Yeah.
Cool. And we can cut this off air if Hart and Rose listen to this, but like what's the deal with the rent split? You paying a little bit, like you helping them out, or like what's the deal?
I think I'm paying a little bit more than I probably like should have to, but yeah.
Wow.
And there you hear it, guys. Devin Rose and Stephen Hart leeching off Lindley.
You just gotta get. You're just like opening the door though to introduce the buck bed opportunity, which is exactly what I did with Caravan. Like take the nicer, bigger room for a little more rent, and then it's like, oh, hey, let's just have this guy move in, and this guy and his little brother.
Dude, should we try it?
And now our rent is super cheap.
Yeah.
Yeah.
All right.
Yeah. Anyways,
getting back into it. Last week in R&D.
Yeah.
Big moving week, as Kyle mentioned. Dude, moving.
No, bro, we stay away from the rent stuff, dude.
moving out of 4-3, man. That shit's sad. I don't know. The new facility is crazy. Caravan, have you been inside it yet? Dude,
still haven't seen it.
Like you can't understand the scale until you actually are in there. Like I saw the pictures and the videos that people have been posting. I was like, it looks pretty tight, but dude, when you get in there, it's like inside of a Costco or something, you know? It is just like, it's massive, dude. It's so big.
Dude, I'm down to not see it. I'm down to not see it until I have my first day of working in there.
Dude, Lindley was just driving his truck around inside it in circles, right? Like imagine 4-3 trying to navigate a car in there, right? Like, dude, you could just drive laps with a truck in that thing. It's so wild.
I feel like it's gonna look even bigger when we get stuff in there. I feel like that's always what happens.
The ceilings are so high.
Yeah.
Crazy.
Yeah. Well, yeah, we'll actually be able to have full size cages in there, which is exciting.
I think we can pitch Joe pretty hard on turning this one room near us. It's got these windows into like a desk area for us, and then a podcast, communal room kind of a thing. Because the R&D
are there any offices right now? Are there any like actual closed areas for offices?
Yeah, there are. I don't think any of that was intended for R&D though. I think ours is going to be out by the lab. We'll be able to build that.
And one of them is going to be like, weren't we talking about having like a conference area, like a big room where we can?
Yeah, I think there's going to be a conference area, like like a media content area, you know, for like plus videos and stuff. But yeah, it looks really tight. I'm like more excited than ever for this like COVID stuff to start wrapping up, because I mean, we would have been, had COVID not happened, would it have been a June open or a May open? I honestly don't remember. Like, was it
June? I think June.
It would have been a June open?
We were supposed to have a soft open at some point, but I'm not sure when that was going
Like
to
in
happen.
early May, right? Yeah.
I think sometime in May, and then we were going to full open, I think, in June.
It would be so cool to be training athletes in that facility, but either way, it's going to be dope when we can. Especially, I was also just thinking of it in terms of like, I was telling Lindley when we were inside 4-3, like tearing stuff down, you know, before we actually went over there, I was like, yeah, honestly don't know how much like we'll even be going into the like new facility when all this wraps up, right? Because like R&D, we can work from home so much. Like we're not necessarily essential at the facility kind of thing.
Yeah.
And like got a pretty fire work from home setup going. But then, dude, when I got there, I was like, okay, yeah, I'm definitely going to want to come into this place a lot just because everything is under one roof now. Like, even though 2-4 and 4-3, like the training floor is like really close to our desks and stuff, I don't know. It's just kind of cool that like everything is now happening under the same roof. So like when you walk in, you're going to walk through the training floor, you'll like see the athletes, see the trainers, coaches, all that stuff going on. So I don't know. I think it'll be pretty sweet environment once it's all said and done, and it's just so goddamn big. But 4-3 was sad. Seeing 4-3 in the state it is now, no equipment, no lab.
That's what I'm saying. I'm trying to not see that either. Trying to not see 4-3 empty, and trying to not see the new facility.
Yeah.
Caravan, when you got here, was there stuff in 4-3? Like, was it already built out, or was it still like the kind of bare bones, just tripods, a bubble, and then some desks?
It was more built out. Like there was turf. There was turf when I first started.
Yeah, for sure. Because you started fall of 2017, right? Because it was still pretty.
No. I started like the very beginning of 2018, like January 5th or whatever.
Oh, for sure.
Yeah, we're gonna be like one of the few people to see it full circle, like empty to empty. From summer 2017. Crazy. Just like no turf, anything, mocap cameras on tripods, just a mound and like a single like sock net back there. And like our desks were the folding tables.
Fold up tables.
And now they're just like, we just have like 30 of those like sit to stand IKEA desks piled up in the new facility room. It's like
I honestly think weird flex, but I think I may have been the first one to build one of those IKEA, like the first Driveline IKEA stand-up desk.
Oh, really?
I think I
but we're the first person to build it backwards, though.
That's what Caravans did.
Nice.
Yes. Yep. Even just seeing the lobby, like mostly empty, you know, like all that's in there now is like Joe's desk and your desk, Caravan, are the only desks that are up. Mine's down now too. A lot of shit went down in that lobby. Because when did we move into the lobby spot? Like over a year ago?
I'm trying to think. Yeah, I think beginning of 2019.
Yeah. So probably.
Yeah, that sounds right to me.
Probably about over a year at that desk, fucking side by side, squad gang.
A lot of stuff the security cameras captured, and that I don't know. Okay, obviously without going into details, do you think anything off the security cameras in the 4-3 lobby will ever come back to, I'll say, bite us back? You know, like Bodie being sentimental and just like scrolling through the cameras, like, you know.
Is that a possibility? Yes. Is that possibility now greater with you having just said this? Yes. Do I think it'll happen? No, I hope not. And also, just to be clear, my name is not attached to any of that. My hands are clean. My hands are clean in all things that happened in that 4-3 lobby, especially in the late hours of the night. Yes, I was not involved with any of it.
Anyways, what'd you do for last week, Lindley?
Yeah, glad we settled that. I already talked, dude. Anthony's up.
What'd you say? Oh yeah, just moving. Okay, yeah. You go, Brady, and I'll bring it home with the our first transition.
Nice. I helped out with the move a bit today, starting from the end. A lot of last week has been planning some Black Ops projects that we'll be able to talk about next week. Also, just ton of meetings with other things. Actually, working on. I guess I can talk about it now because Tosh already announced it on that podcast. The main thing working on Pitch AI actually. So with
Tosh announced on what podcast?
I think it was with PBR or something. It was something about PBR. I'm not quite sure. Tosh was on a podcast recently. He brought it up. I saw it tweeted out. He mentioned what we're doing with Pitch AI. Pitch AI, obviously working with Dr. Mike Son. Super stoked about it. Been doing stuff with him for a bit now. It's like a single camera biomechanics solution. Obviously, it's not as good as the like Marker mocap lab, but it's better than nothing, and it's going to be really great for remote training. Being able to get like decent biomechanical data from just like a side view with your iPhone. We're working on like integrating that into Track, like automating that system, and also just taking everything that we know from the biomechanics lab with like the more robust data set and trying to find out what we can pull from just like, a side view iPhone video. So a lot of work on that project.
Can we talk about any of the like things you might be reporting on and like using to guide programming, or is that going to be something we have to wait to talk about?
We'll probably wait to talk about that. I think because we're still just also like figuring it out, trying to find out like where's the meaningful signal.
Yeah.
Like what to pay attention to, what to ignore, and that's actually just like a good point in general with like tech and all this data is like knowing what not to look at. Because actually, when I was talking with Dean about implementing this, we were saying like, should we include all the data, include all the graphs? It's like if we don't feel confident in like one of the graphs, or maybe there's like some inaccuracies, should we just like leave it out? Because like people may read it wrong, kind of a thing. So yeah, but that's what I've been working on last week, as well as some Black Ops projects.
Yeah, it's funny you say Black Ops because that's my largest toggle project for this week.
Oh, really?
Yeah.
I mean, not all of my stuff is Black Ops. It's Black Ops for the podcast. Say that.
Yeah.
Like you guys know about it, but your stuff is more Black Ops. You've been stealthily working on that.
Yeah.
Why don't you tell everyone? Why don't you tell everyone about it?
I mean, well, first off, your boy may or may not be exchanging emails right now on potential patents.
Wow.
And by may or may not, I obviously mean may, because otherwise there'd be no reason to say may or may not.
Yes.
But I'll segue the stuff I'm working on that I don't want to talk about right now publicly into kind of our first overlay, like transition, and a potential continued EDU. Little spiel I'm gonna go into in tomorrow's morning R&D. And I'll say, actually, the reason I thought of this was because I was telling my brother about like the project, and his like natural question was like asking, like, how could you tell the error between predictions and the truth, and just like overall general questions that come into place when someone like kind of like who's not super experienced in modeling predictions and errors and everything asks. So I thought it was like a very good segue for people who aren't actually like, necessarily super experienced in machine learning or data science or whatever. Mm-hmm. But the general topic at hand I'll address is when you're attempting to predict something or, devise a model, implement a machine learning algorithm, all that kind of stuff, what the general process is. Assuming you have good data, because a lot of it, like a typical shtick or like phrase that people say is most of the work comes into actually cleaning data and getting like really good data when it comes to like a data science project. But say you are attempting to model something, and I'll use a discrete example. I'll use the swing profile report that we sent like 54 reports off of, and Tanner and I wrote a blog, and I went a little bit into detail on how I modeled that. But to kind of reset it here on a podcast, for the swing profile report, which will be soon be coming to you in other formats, but the idea there is that I'm predicting expected batted ball metrics of just blast data. So I get all the swing, all the swing variables like bat speed, attack angle, early connection impact, all the whole slew of stuff for blast. And then off that, I predict exit velocity and launch angle. So what makes it easier for me and us in general is we have a huge data set from in-gym of hitters on blast, hitters on hit tracks, hitters on blast and hit tracks at the same time, hitters on blast and hit tracks over like a long period of time. So I have like multiple different data points. I do a little bit of testing and collect my data set. The main gist of it is when you have a data set of, there's two, to kind of just walk it back one step. There's two main forms of machine learning, like modeling: supervised learning and unsupervised learning. I don't know if you guys have ever heard of those terms before, but supervised learning is where you know the truth variable. So think of it as Y, right? Like you build a model to predict Y. What goes into model X? X is the variable you use to predict Y.
Yep.
So supervised learning is where you know Y. Unsupervised learning, the other like large part, is where you don't know why. And that can be,
you just like let it run free, right? Like it's just like you're just letting it find the answer for you.
Right. And it'll find similarities and like patterns in the X data. Mm-hmm. Like for example, a lot of times in the beginning, like now it's a little bit more concrete, but in the beginning, like people would build big models on like spam emails, right? Mm-hmm. So like to begin with, you don't know exactly what a spam email is, right? So it's almost like unsupervised learning in terms of like, okay, well, if these like combinations of variables are in there, this is probably a spam email, even if I don't know for a fact it is because it hasn't been sent yet, right?
Yep.
Like spam emails change over time, all the time. But in supervised learning is a little bit more straightforward. And in terms of like sports analytics and overall data science, supervised learning is definitely the more common one. So in this instance, it's definitely supervised learning because we know we have hitters. We have hitters batted ball metrics and we have their blast data, and sometimes it's paired, sometimes it's not. But essentially what happens is we have this big data set. Y is, in this case, we'll say the peak EV, and X is all the blast metrics.
Yep.
So we split our data set usually into either 2 or 3 large categories. If you have enough data, you'll split into the 3. But the basic 2 ones are training data and test data. And training data is what you build your model on, and test data is what you test the data on. And to kind of preface it, depending on the data size, you'll have different splits. If you don't have that much data, you want more data to go into training data so you can like build a better model.
Right.
So say you have, and by that I mean, say you have like a couple tens of thousands of data points. That might seem like a lot. That's not a lot compared to like larger big data problems. So you would probably throw 70 to 80% on training data. And again, these are like very general parameters I'm speaking of. There's a lot more nuance when it comes to like what kind of data, are there outliers, are there patterns we have to control for, are there seasonal changes, all this stuff. But essentially as like a core concept, you throw in a majority of your data and training data, unless you have like millions of like data points, then you can like distribute it a little bit differently. But you'll throw it in the majority into training data. In that case, you'll build a model on those Y variables and those X variables. And then the test data, say that's 20% of the data, you hold that out, and then you test how good your model is on that data, because that data hasn't been incorporated at all in the training data. And that's what a lot of people mean when they talk about overfitting. Because if you train all the data set, the whole data set, your model will like learn from that data. And if data going forward, because when I build a model like that, if I build expected batted ball metrics off someone's blast data, I want to build it for everyone, right? I don't want to just be able to build something that predicts, like that easily predicts what we currently have in gym. I want to build it for, random people that send in the reports off Twitter, people going forward that use that report. So in that case, I wanted to be flexible, and I wanted to work on new forms of data I haven't seen before. So therefore, I need like a test data set that I hold out, and then you bring in the X variables from the test data, plug that in the model. There you get the predictions, and then between the predictions and the actual truth variable, the actual Y of the test data, because you know that because supervised learning, you hold that out and you compare the predictions from your model to the Y data, and from there you can depending on what kind of error metrics you want to do, mean absolute error, mean absolute percentage error, mean squared error, root mean squared error. There's a couple of things you could do. And by the way, as a quick segue, also something I did last week, I went on the Hitting podcast and actually talked about like validating technologies and talked about like accuracy analysis, correlational analysis, and distribution analysis. And I talked about a bunch of those error metrics as well.
Yeah.
I'm trying to convince Stauderopoulos to release it faster because I'm not going to lie, the podcast episode was pretty fire. I just went on and just roasted Stauderopoulos for most of it. I put together a PowerPoint slide of just a bunch of his pictures from Instagram, shirtless, just like stretched out, so the aspect ratio is way off. So his stomach looks like it's taking up like 50% of the PowerPoint background. But anyways, so that's the core concept. Training data, you build your model on that, and then you need something to like have that's not in the model, so you can get like a truer sense of what the error is. Because the training error is almost always going to be lower because that goes into the model. The model learns from the data you put in. And if you have a really large data point, depending on what kind of model you want as well. If you're doing like a more complex neural network, what you would do typically.
What's a neural network?
That's a topic for next podcast. But I mean, I'll do a quick overview of neural network. But I also famously. That was my first topic when I first joined Driveline and at an all hands meeting, and I just went over everyone's head. But I'll try to do a very simplistic definition of a neural network. It's essentially something where you take in all the features or all the different variables, and then you kind of condense them. You usually apply like sigmoid functions to them, but you essentially just think as like you take models, you apply models to those data points. And those converge into separate nodes onto. Okay, you know what, dude? This is don't ever ask me about neural networks again on air without.
Dude, you're doing fine until you said sigmoid functions.
Yeah. Caravan, I got a question.
Okay.
So
if they don't know,
we'll talk about neural networks. We'll talk about neural networks next episode.
Last week we talked about the defensive metrics and how they were testing their model on the same data they trained it on. So like. Say you'd already talked about with a limited data set, you're going to want to use most of the data for training and the rest of it for testing. In the case that you have like even less data than that, is there any like world where using your training data to test is fine? Or is there just some like adjustment? You have to be less confident with the results, or some like way you can adjust those so you can still have enough data to train and also like have the ability to test it.
You're saying like based on, is there like a certain amount of sample size where it's just like you just got to train all of it?
Well, like, yeah, is there any, should you 100% like never use training data to test, or is that something that you can kind of you could just like accept that you have to use training data to test if like within the constraints of a problem?
Yeah, I mean, if it's really small set of data, you might as well use everything to build like a decent model. It's like one of those things where there's no like strong rule. I would say if possible, like at all costs, like try to like hold out some data, because whatever you train, unless it's like a perfect representation of like what the data is always going to be, it's almost always going to overfit, right? Like say I'm training, say I have like 10 data points and they're bat speed metrics, and they're all from like in gym numbers, and we have some youth, but we don't have a ton of youth. So if they're all like pro and college players, and then some youth guys come in and want to test their data, our model is going to overfit so hard to the guys we currently have, right? So then it's going to be like, okay, whatever relationship pro guys have between their bat speed and exit velocity, that same relationship is going to get applied to the youth guys. So like that stuff happens all the time when you have, and like the best thing you do in that case is like not build a better model, just get more data, right? Get more data that represents like a larger segment of the population, that kind of stuff. But and that goes a lot into like the test. Like there's multiple. I was doing a pretty general overview, but there's like multiple ways of kind of covering all your bases. There's stuff like leave one out, cross validation, where you, let's say you do like a 10-fold cross validation. Actually, would probably be a better way of explaining it, where each time you take a 10th of your data set out and then treat that as a test data, and then do that for every 10th of the whole data set. So in that case, you kind of technically treat every single data point as both a training and test data set, right? And it tells you like whether or not, okay, like this, like the test error is especially high when this 10th of a data set is held out. So I mean, in that case, that's like not really representative, or that's like too condensed, all that kind of stuff. But as a very general overview, and the main message of my, main message of this overlay transition is, when you have a large data set, the idea is you want to split a part of it out to train a model on it, and then you want to split another part of it out to kind of evaluate and see how strong your model is. And when I preface it with saying usually it's like something's going to be like threefold. For neural networks, which I'll go into more detail later on, there's a lot of parameters involved in those neural networks. And by parameters, I mean like kind of if you think about like the most basic model, or like, say a basic linear model where it's like y equals an intercept, right? An intercept like 3 plus the slope of times the variable. So like if you've ever been like a classic math class would be like y equals whatever variable they want to use for the intercept. Say like a plus b being the slope, times x, and b is a parameter in that case. So in a neural network, there's a ton more parameters. So you'd actually hold out a separate part of the data. You'd call that like the validation set, and you would use that to train your parameters on it. Then you'd bring in a test data set and have that be completely new, and then train on that. Or sorry, not train on that, but like use that to evaluate the actual model results. So even the parameters don't get influenced by the test data set. Mm-hmm. So I guess main message is, if you're trying to build a model, just keep in mind, don't overfit. And if you don't know what overfitting is, and I didn't communicate clearly, just look it up. But that's like I think that's like one of the number one kind of things like people run into when they're like first like trying to build something kind of complex, and they have all this data and whatever. But overfitting is like a very real thing, and I think it's like something that most people don't always consider to the utmost.
I think that was a good topic.
But your boy butchered it, or what?
No, I think you went real technical.
I think the first part was really fire. I think you did a good job explaining the test first training data set.
I think you think you just fucked me, Lindley?
Huh? Yeah, I did.
Lindley served you up a not easy question, but also I think just a better preface and general understanding of like machine learning and neural networks from like a very far away view would have been helpful.
Yeah, that's what I was kind of going for. Like, what is a neural network? Is it's like a category of like a machine learning?
I mean,
model, right?
My understanding is it's like definitely not as deep as Caravans with sigmoid functions, but just like you're just like trying to teach something to like do something based on like task specific constraints and examples. So you're just like feeding it all these examples and trying to get it to learn how to do this task, and then like certain variables and parameters are adjusted in the examples that you feed it, and then that's how it like learns the outcomes. Like if you want something to like get from point A to point B, and on days when it's rainy, like the example like grabs an umbrella, it's like, okay, well, to grab an umbrella all the time? No, only when like the forecast says it's rainy. So I'll grab an umbrella that day, and then you just keep feeding it like more examples to learn like how to accomplish a task or whatever you're teaching.
To be honest, though, that's like a definition of an overall just machine learning model, not just neural network. Like the difference. So without saying sigmoid again, some of the nuances that come in a neural network is the idea of layers. Like you have certain variables that go in, and there's multiple layers. Like that, choosing that itself is a process that you need to like go through the proper.
It's like a decision tree element to it.
But much more complex and much more honestly accurate. Much more accurate. Like if you have enough data, neural networks gonna outperform most other algorithms. You have the input layer where you have those initial variables, and then like I mean, honestly, I'm just gonna screen share really quickly. This is gonna be much easier on a quick screen share. I'm literally just gonna Google images neural network.
I'm sorry for everyone listening out there. This is not gonna be.
No, I mean, it's gonna be very quick. But yeah, I mean, it just looks something like this.
Tune into the YouTube to see what he's talking about. Yeah. Okay.
Yeah. So this looks like overwhelming. And for the record, when I said sigmoid functions, it also doesn't have to be a sigmoid function. It could be a softmax function, if that clears up anything for anybody.
I'm sure it does. It does.
But yeah, so between where you see all these like kind of links between the input layer and the hidden layers, and the output layer is like your outcome, right? Basically the predictions. But between these, like these input variables will combine with certain weights that you like teach the model, and it'll run through the whole loop, then it'll like back propagate, which means it'll like loop back and then see like what how correct the weights were, and it'll like reteach itself better weights. And by the way, for neural networks, like it seems overwhelming, but there's a ton of like open source stuff, whether even in R, Python, different like programming languages. If you have enough data and you have enough like a little bit of like coding savvy, you can set up a neural network without like having to understand all the math nuances behind it.
As long as you have the clean data, though.
Yeah, essentially the whole like kind of like flashy aspect of neural networks is just like being able to relearn weights for each variable layer by layer. And I will stop sharing my screen and stop talking about. Stop talking about neural networks.
I thought we talked about how many tabs you have open, man. I thought you were gonna get that problem under control.
Yeah, and in my defense, that's actually only one window though. I only have one window open. Because remember, I used to have that for like 4 windows, so yeah. I have gone it much better.
Nice.
That was a good segment.
Yeah,
that was a good segment.
Yeah, that was fire. And part of it,
I don't need you to patronize me.
Part of it actually is kind of talked about. Like part of that idea is talked about in the social media stats segment that we can get into now.
I just hit the transition. All you, Lindley.
Kyle Wasserberger at Auburn.
Dude, is that your burner account, man? That just sounds like a name. Honestly, this dude even looks like you. I'm not kidding. Yeah. I think when I first saw this dude, okay, he doesn't look like you that much. I just looked at his profile.
I think he's Nate Montgomery's buddy.
Oh, really? But it just looks like someone that could be you, like from far away. Like you got some like kind of like trendy looking stuff, and then I don't know, got a lot of like degrees and everything in his bio.
What? Unreal, man. All right. Anyways, yeah. So he starts off this thread talking about how a lot of people in baseball talk about energy transfer from the ground.
Do you want a screen share?
Oh yeah. Shoot. Sorry, guys. Yeah. All right. So I'm sharing my Twitter screen.
Yep.
Right now. Yeah. So Kyle Wasserberger is a PhD student at Auburn. He starts off this. Wait,
sorry. Last thing. You're not even gonna follow him back. You're gonna shout this guy out positively on social media.
That's a good point. That's my bad, Kyle. If you're watching this, all right. I'm gonna start again. So he starts by discussing how baseball folks talk a lot about energy transfer from the ground up, the kinetic chain, how efficiently a pitcher transfers energy from the ground, from their block up through their body to their arm will help them, or will be indicative partially about how fast they can throw a fastball, for example. And he mentions how we use we use basically proxies to measure that, like the timing of peak segment rotational velocity. So when does the pelvis rotational velocity peak relative to the torso, relative to the arm? And so it looks like he spent a good amount of time looking into actual energy transfer. And the way that he defined energy transfer is a little bit, I'm not super sure how he defined it. It looks like it's a rate of energy transfer. Based on this plot, I'm showing a plot of peak rate of energy transfer versus pitch speed, and it looks like there's a direct relationship between the two.
Yeah. Between the trunk and the humerus.
You should DM him right now. Let's see if we can answer live on the podcast. Just DM him. How do you define energy transfer?
Yeah.
It looks like it's being measured in watts.
Yeah. So watts is a rate of, or like how fast energy is changing. So he just talks about how he's able to measure energy instead of just using rotational velocities, for example, to try to describe how a pitcher's doing that. So he has this data set. He's comparing the peak rate of energy transfer from between the torso and the humerus. So from like your upper body to your arm. And he compares that to see how well or how correlated it is with pitch velocity. And he found that there's a strong linear correlation. It's R squared of 0.68. And but then he looked at the data and saw that I'm putting the graph back up of the plot, the energy transfer versus pitch speed, and it looks like there's an exponential decay curve. It doesn't quite look linear, and this looks like a very clean data set to me. I don't know what you guys think about this as well, but
no, like outliers and stuff.
Yeah. But anyways, it looks like there's an exponential decay. So he decides to put a nonlinear model to it and finds that the R squared improved. So he got a 0.71 R squared versus a 0.56 when he ran both of the models. So he started off with a 0.68 R squared with his original test. Then he implemented the nonlinear test, and he got a better. Not only did he get a better R squared with a nonlinear, but it made the linear model go, or like it wasn't as related to, it didn't perform as well. So Caravan could probably talk more about that, but basically saying that the nonlinear model describes the data better. So basically, I don't know. I just thought it was really interesting because he actually like looked into energy, and I think that is something we've talked about it. Anthony, Joe, and I have talked about it. Oh, Dean brought it up last week, and we were talking about how we can use energies to look at sequencing differences between people and how well somebody, or how efficiently somebody's rotating or propagating energy. And so his takeaways are: rate of energy transfer between the torso and the humerus is related to pitch speed. So guys who propagate energy faster tend to throw harder, and it seems to be a nonlinear relationship. But he also talks about how it's his data set was only in up to like 80 miles per hour. So they didn't have that many elite throwers. So he talks about how future work would look into more elite populations to see if this trend continues. And which is why I thought it kind of goes along with the idea of overfitting. So like if you were to just use this data to create, like just say that rate of energy transfer affects pitch velocity this much, and apply it to any general like throwing population, even though it's based off only guys who throw 80 miles an hour and slower, it may not perform very well with guys with a population that throws harder or transfers energy faster.
Yeah.
So
Yeah, and one thing I wanted to mention is I thought it was like pretty interesting that the adjusted R squared is the same thing as the R squared. Because for people that don't really know what adjusted R squared is, sigmoid function. Not just kidding. But adjusted R squared basically gets docked for the number of predictors you have. So where you had, I think, where you had like mass and energy transfer versus just mass. The more predictors you add, the more your R squared or adjusted R squared will get docked. Because in theory, if you add more variables, you can boost up to R squared. But like the more variables you add, there's change of collinearity and all that kind of stuff, which means like one variable helping explain another one. So adjusted R squared like wants to make sure that you get kind of docked for including like more predictors. So adjusted R squared can never be higher than R squared. It can only be equal or less than. So the fact that it was equal means the energy transfer was like very significant.
Interesting. Yeah. Yeah, I get super domed up on the whole kinematic sequence energy transfer thing when it at the very root level of like what metric you're trying to look at, especially since looking at the hitting stuff as of late. And that's something that on the hitting podcast that's what I along the lines of what I was asking Greg Rose on that one with like the kinematic sequence could be different if you choose to look at like a different metric, right? So for instance, KVS looks at pelvis rotation in the Z, torso rotation in the Z, and then maximum upper arm speed and maximum hand speed. And with those like upper arm speed and hand speeds, you introduce like axial rotation. Like that's what I've asked you a bunch about that, Lindley. Like I still don't know if like just how much like additional artifact can be introduced by those movements, and if they actually like should be accounted for in those like kind of calculations. And then I wonder if like on the on the pitching side we do right like pelvis rotation, torso rotation, elbow extension, and internal rotation of the shoulder. Like if you're a non-rotate, like if you're not that rotational of a thrower in the
Was
Z,
good. I'll admit I'm not that rotational.
And you're like more linear like Caravan, and you create like maybe more momentum, more energy with like trunk flexion and extension, like lateral tilt. That's just not being accounted for.
Mm-hmm.
I don't know. I think it's like a pretty interesting thing with it.
Also, I missed a step here in his like analysis. I forgot Caravan mentioned it, but he before moving on to the exponential decay model, he factored in mass. So
yeah,
first did energy transfer, and then wanted to see if body mass also had a.
Actually, a quick tangent off that. I actually think it's like a pretty interesting baseline to use in general, since when you do have like a wider population that does include different levels of talent and different ages of people. I think like mass is almost a like universal, or should be a universal like baseline when predicting like velocity. And it kind of brings me up to one thing that I'm working on, and I'm kind of setting this up as a project for like outsourcing to other people. Currently, Mike Tampolini, I'm trying to set up the project for him to kind of work on, but I'm looking at force plate metrics and biomechanical metrics. But an easy one can just be mocap velocity. And I haven't told him this, but I just ran like a very quick correlation spanning across like a pretty curated data set where there were no repeated measures, so nobody had more than one data point. And a few had like positive metrics, but also body mass off like measured from the force plate test, and mocap velocity had like a 0.4 something correlation.
Yeah.
So I think anything significant from the force plate database should have either you control for the mass somehow early on, or it should have a stronger correlation than it does with body mass.
Yeah,
go ahead.
That's how most force plate studies do. They report as a like relative to your body weight, so it's like 1.1x body weight in terms of like GRF. So like that's how most force plate studies are done. So in terms of like force plate testing, you would want to know, is he putting like 2.2x body weight GRF into the ground? I don't think there's many studies that would look at, or just like past research. That's typically how they like report it at least.
Right, but I mean, even like jump height, right? Like jump height, that's not like factor. I mean, like obviously body mass factors into jump height, but I think like if a correlation of jump height is like weaker than body mass, I think either you got to somehow adjust for body mass, or not like put too much. I don't know, especially early on when there's like a smaller data set. I think jump like that should be basically, I'm restating that should be a solid baseline when it comes to involving forces and torques into measuring things that are very influenced by body mass.
Yeah. Oh yeah, most definitely. You can get away with just being big.
Yeah. Also, really quickly, Lindley, do you remember what you got on your hitting podcast appearance, like time wise on the rapid fire questions?
I got 3 minutes something, like high 3 minutes, I think. What'd you get?
He's milking it.
You ever heard? Listen, dude. You know how there's been 15 guests, right?
Yeah.
Going in. Do you know what the highest, the lowest time was? I should say.
It was low threes, I think.
When I went, it was 2:56.
Okay.
Spoiler alert, it ain't anymore. It ain't anymore.
I bet your answers were funny too. Mine were just like, it's like practical and.
I actually copied one of your answers because I listened to your podcast, and there was one. I was trying to go fast. So most of mine were decent answers.
Oh, you're even
there were a couple times. What? No, I wasn't. I didn't think I was prepared. Right? Like
the cat's out of the bag. The cat's out of the bag.
I
knew all the questions in advance,
and I almost froze. No, the questions are different, but I almost froze at a certain point.
They were different?
And then I think somewhere different.
I'll say
okay.
Man.
I'll just tell you. Listen, I'll tell you the one.
Man.
I'll tell you the one I copied, and I mean it's still kind of true.
The neural network talk was better.
All right, never mind.
No, I want to hear it. I
copied your pet peeve. On the dishes. Cause it doesn't even actually trigger me that much. I think I just like looked over and saw like a stack of dirty dishes. I was like, oh yeah, I hate when people don't wash their dishes.
Nice.
Good. New record holder on the hitting podcast.
Yeah, that's huge.
If it ever comes out, I don't know. Who knows when it's going to come out, when the episode's going to drop. Yeah. Why not?
Should we get into study?
Yeah.
Yeah, get into it.
Yeah, wrap us on the last segment.
All right, I'm going to share my screen again.
Research article review of the week.
So this week, it's a biomechanics paper. It's called Fastball Velocity and Elbow Varus Torque in Professional Baseball Pitchers. It's in the Journal of Athletic Training. It's a study out of ASMI in Alabama. So they look at the relationship between velocity and elbow varus torque in professional baseball pitchers, obviously. Basically, they just it's a retrospective study and a cross-sectional study. So they just like took a bunch of data they had in their database already. And there were some qualifiers. So they looked at pitchers who had thrown at least 5 pitches, who had a fastball velocity spread of at least 5 miles an hour, and no single pitch accounted for more than half of that velocity range. So basically, they just only included pitchers with a good enough representation of velocity, like a range of velocity, so that they can find as confident of a relationship between velocity and varus torque as they could. Used optical motion capture, and they looked at between subject differences and within subject differences. So they basically looked at, within subject, they looked at how elbow varus torque responded or was related to ball velocity, and then between subjects, they did the same thing. But basically I believe they took the average of each pitcher's velocity and varus torque, and compared between subjects. So a person who has a higher average ball velocity, do they also have a higher average elbow varus torque? And what they found was that between subjects, ball velocity was not a great predictor of elbow varus torque, though it was significant. I think
should be noted that elbow varus torque was normalized for height and weight.
Oh yeah. Sorry. Yeah. So the varus torque was divided by body weight times the height of each subject in an attempt to make those values more comparable, because elbow varus torque or torques are calculated using lengths of segments and inertial properties like mass. So, for example, the mass and length of the forearm is scaled based off a relationship we can assume is pretty accurate between body height or body weight and the segment of your forearm. So it's just like
by the way,
2% of body weight or something.
I didn't realize ASMI. I mean, you guys probably realize this because you guys would have way more experience like reading through these studies. I didn't realize ASMI was built like had that decent of a data set.
Oh yeah, ASMI has been around for a while, collecting all sorts of
like I'm saying like now like if I think about it, it seems obvious to me, but I didn't realize like it's not like something that was present in my mind going in.
Oh yeah, they got all sorts of data. That lab's awesome.
Yeah. So the results in the discussion are pretty straightforward. They just found that between subjects, normalized varus torque, there was only a 0.076 r squared value between ball velocity and elbow varus torque, so not a great predictor.
Mm-hmm.
And within subjects, there was a 0.95 or 0.957. So 95% of the variance in elbow varus torque can be it is what's that? 95% of the variance in elbow varus torque is
explained by velocity.
Explained by velocity, yeah.
Within subject for you.
Yeah. So for each guy. So within a single guy, when his pitch velocity went up, so did his elbow varus torque.
I'd actually like to see those numbers in our gym, because the assumption would be that that's not the case, because we actually see like changes in that value as like that's basically like if we see efficiency increases in gym, that would argue that that like correlation wouldn't be as strong, which would make sense too, because we train athletes, change their mechanics, the way that they deliver, kind of a thing, whereas ASMI is mostly just like measuring and collecting data, right? Like if we are efficiently changing people's mechanics, wouldn't that correlation wouldn't be as strong.
Yeah, and that's what they talk about. They talk about that in this study, why the between subject relationship isn't as strong.
Yeah,
because there's mechanical differences that can lead to elbow varus torque, and this is an acute thing. So all 5 pitches were within the same session.
Yeah,
I believe so. Like it's not and also if we're using efficiency isn't going to be the same like scale as absolute elbow or like normalized elbow varus, because somebody can increase both velocity and elbow varus, but their efficiency can go up.
Yeah.
Or down, which so like it's if we see efficiency go up even though velocity went up, that doesn't necessarily mean that their varus torque went down.
Right. I was gonna say really quickly, if you can scroll up just a little bit on the page right above, and I think like this first off, this graph right here kind of shows one of the concepts I was trying to explain during the hitting podcast, the idea of like fitting slopes specific to a subject rather than the overall line, because the black line is like the overall correlation line, but as you can see, like each person
try to explain the graph,
right? So there's a lot of data points on here, and there's one thick black line in the midst of it, which is the looks like the overall correlation between all the data points, and each color is each color with its own kind of color data point represents it looks like the relationship between for one subject. So for example, anybody looking in the top left corner, there's a purple line that's got about 5, 6, 7, 8, 8 or 9 data points, and it has a line fed to it. And I was going to mention this in relation to Brady talking about testing stuff in gym. The biggest difference in terms of what we'd be able to kind of cross check and reference is our amount of retest, right? Like we have most people might have 1 retest, maybe 2. 3 is already a kind of a select group, whereas like some people here have like 5+ data points.
Right.
So that'd be the equivalent of like someone doing 5+ retest. So our own, I mean, we can still definitely test it and run it, but the biggest difference would be we have way less data points to fit per subject.
These are, I could be wrong here, but I believe, I guess it doesn't say that it was acute. My assumption was that these are all within the same session.
Oh, really? Oh, like
so like all pitches were within the same session. But I guess that would be like that kind of seems hard to believe that you're going to find 450 pitchers who had a velocity range of more than 5 miles an hour on max intent throws, because these were all max intent throws. So
it looks like I mean, the most extreme one is the green guy, if you can see, and it looks like his lowest throw is just over 36 meters per second, and then his highest is almost 42 meters per second. That seems pretty nuts.
Yeah, that's a lot.
But I mean, that's honestly that's kind of a lot. And I mean, unless he was like injured during a few of the data points.
That was a selection criteria though. They couldn't have been injured within a year. So, oh man, I'm trying to.
I wonder if we could build out something decent then if we just included all pitches instead of pitch averages.
Yeah.
Even the group that has, even if it's just assessment to retest, at least that's 6 data points. You start to introduce more. Maybe at the new facility we should push for 5 pitch averages. More data.
I'm in on 5 pitches for sure as a rule. But I do think there's a difference between like looking at it in terms of like sessions and just like more pitches per session.
Right.
But I mean I'm 100% in on 5 pitches. Yeah.
Yeah. It doesn't look like they specify here, so I wonder if they included both. But an interesting thing about the study that I don't necessarily agree with, they look into the correlation between fastball velocity and certain performance metrics. So there are a few plots here showing the relationship between fastball velocity and FWAR, ERA, WHIP, and BWAR. And their argument is that these relationships are pretty weak, and fastball velocity doesn't explain a lot of the variance in these performance metrics. So in their conclusions, they talk about how pitchers should deliberately, they say specifically, deliberately throw slower when they don't need to throw hard, and they should find a minimally effective velocity, basically, and work on command. So I think this study is super interesting, and I really like how they talked about it and everything, but these conclusions just seem a little bit like far-fetched and not necessarily I don't know, like for one, how do you determine a minimum level of pitch intensity necessary to get people out? Like, what is a good enough threshold when you're pitching to say that like I only have to be that good, so when I throw this hard, I'm that good, so I don't have to throw any harder than this or try any harder than this. They say developing command is another way to alleviate this relationship, which that also there's not a lot of like data suggesting that one, how to develop the command, or two, like that's gonna like solve this problem.
Yeah.
And I'll say really quickly, usually when it comes to building some sort of sabermetric or, just an overall analysis, looking at fastball velocity, I think one thing that we do in gym, and I think a lot of other sabermetricians whose work I admire do, is not just looking at overall fastball velocity against something, because there's a reason, right? Like there can be subjectively speaking, shittier pitchers who only got into bigs because of their fastball, and then they might not be that good. Their fastball got them in, and then like that data point might drag down any sort of performance indicator. So usually what we do is we look within that pitcher, if increasing or decreasing their velocity, how does that affect their actual performance? So usually like a common bracket will be, pitchers who gained 1 mile an hour on their fastball velocity, how did that next season performance change, or what's that data look like? So that's like funny. I think a more fair and common way to looking at fastball velocity when it comes to performance metrics.
Yeah, that makes sense to me, and it's also kind of crazy because it uses their own like findings of this article against their final conclusion. Like they found that between subject, varus torque isn't as related, or fastball velocity isn't as related to varus torque, but then they still used for this one, they still used it between subjects. Relationship between fastball velocity and these performance metrics to like prove their point. So,
and it's also, I mean, fastball velocity in the lab, that's still like the biggest point.
Oh yeah,
and
they mentioned that in the study as well.
Yeah,
that it might not necessarily be indicative of in-game velocity. So
yeah,
I'm gonna stop sharing now.
Yeah, no, that would be that's a interesting way to go with that conclusion. And I just don't think we see that. I mean, I was asking you guys, the analytics squad, about that. Basically like fastball velocity average relative to like more advanced metrics and
by
it
the
matters.
way, and by the way, actually, I think those R-squared values are strong enough, and those are statistically significant. R-squared value of over 0.1 across 400 plus data points is definitely significant.
Yeah. Like I don't especially in terms of like what other metric out there, like relative to the others, is there anything that just like jumps off the page in terms of like this is the most valuable metric that isn't fastball velocity?
Yeah, well, the thing is, I was going to mention is, I mean, fastball velocity is an intrinsic metric of the pitch. So if you're and you're using that to map to an outcome variable, which is ERA, FIP, WAR, whatever. So I mean, if you were going to say like K percentage to ERA, I'm sure that'd correlate higher. But that by itself is an outcome metric. So that's already explaining some of what goes into ERA or FIP. So by an intrinsic measure, I think, agreed. I think fastball velocity is as high as it gets. You have to compare it, like similar things to compare it to, if you wanted to, would be, absolute movement of fastball, movement of curveball,
command,
spin efficiency of curveball, it's stuff like that. Like it's got to be an intrinsic. If you're going to compare an intrinsic value to an outcome variable, it's already going to be tough to get like a very high correlation. But if you're going to reference it in terms of people who, whatever that suggestion was, you want to like slow down and throw your fastball slower, then I'd like to see, proportion of balls thrown 2 miles or more less than your peak fastball velocity. Show me that, that'd be like an interesting kind of challenge in terms of like how the metrics compare.
And at what point do you have the ability to do that? Because I assume that if you throw 100 miles an hour, you can deliberately throw slower.
Yeah, exactly.
Yeah, but if you're 92 and you drop it down to 90, I mean, you're already probably getting hit around at 92.
Yeah, and the other thing is that like if pitch velocity does lead to success, which like a lot of people have found, they showed it in this, then like more is theoretically better, right? Yeah. So you're just telling a pitcher to just like deliberately make themselves worse in a world where like their livelihood is based on how well they do in the game or whatever. So
it's a balancing act though too, and I do get that, but I feel like it's like, okay, we don't want to throw too hard to get hurt. Well, if you're gonna just like follow that your whole life, you're never gonna throw hard enough to where like the pitches that you throw matter, honestly. Like that's just the nature of it, kind of a thing. So
I was talking to Marissa about it yesterday because the conclusion is that's a pretty sound conclusion in a vacuum.
I completely understand the sentiment, and like that's coming from someone who's had Tommy John twice. Like, I mean, I still completely understand that. Like, yes, if I throw harder, probably gonna experience more stress and like more likely to get hurt. But every time I throw a fastball, I'm not thinking take a couple miles an hour off and try to get it over. It's like my best chance is if I try to blow it by this guy.
And conversely, I think that's what's holding me back. I think that's why I only throw at 70 because I keep thinking, man, I'm gonna get nerve entanglement again. Yeah. I'm gonna get nerve entanglement again if I really spike it up.
Yeah, that's good, man. You killed that last section, man. You killed that way better than neural networks, Caravan. You did that was a beast. What do you mean? There. I'm just saying
what I just said right now.
No, the examples you gave, man. At the end, that was like you came back second half of the podcast. I think
the neural networks was that rough or what?
No, I think it was just it was all right, but you did really well on that one. So it's just like it was really good.
All right, and I'll ask Brady off air how much this is patronizing or not.
I was just trying to end the podcast on that.
Bro, I am sweating right now.
Let's end the podcast on that.
It is absurd. No.